Good morning, guys. I'm Chris, and welcome back to this Sunday's episode of Rift Amps. Back on with the gold tone then. Still making random noises. So let's have a look at the schematic. Do you remember how we said the volume control affected the level of the noise, which means the noise must be upstream of the volume control? So if we're looking at the schematic, we can see we've got, if we're working our way backwards, essentially we're looking at all the circuitry around V1A pins 1, 2 and 3. It's got the two inputs here, high and low, both with a 68k resistor. We've got a blocking cap here, a 2N2. Got a decoupling cap to chassis there. That's interesting. Into V1A, it's bypassed with a 1 nanofarad. So I'm looking through the screen here. I can't quite see it. Yeah, one microfarad cap. Sorry, I should say. Got a 100 picofarad cap across the anode to cathode, and then we've got a coupling, a 222 nanofarad coupling cap. So first things to suspect, as always, valves are a wear and tear item. So are we looking at a noisy valve in this position, or indeed the socket itself? So let's investigate that first and go further. So here it is on the bench. If I bring the volume control up slightly, I don't want to blow your ears off, but obviously at this moment, headphone warning, things might get loud. If I just move V1, it wasn't even in properly. Okay, so let's start by cleaning the socket, cleaning the pins, making sure that valve is seated properly. We'll go from there. The other thing I've noticed is tapping the chassis. Not the chassis, the PCB causes problems. Yeah, like I'm going to do a drum solo. Right, anyway, so let's investigate that. Look at those look at the solder pins on that socket. They don't look great, but they're not bad either. Let's flip this thing over, inspect the socket, inspect the pins, and go from there. Right, so if I just wobble that valve, we're definitely getting some weird noises. This one less so. So we'll just focus on this one for the time being. Let's pop it out. Got some bent pins and some, looks like some hair and fur on that one. Can you see? That's a harmer. If we look at the socket, come on, behave. Can you see this pin here is sunken down in compared to the others? Can I get you a better view on that? See how it's sitting further into the socket? The other thing I've noticed is, see the bubbling on that PCB trace here? Same on this one and this one. So there's some serious heat going on around this socket. Now, if those PCB traces are the issue, there ain't no way I'm fixing that. It's just not worth it on an amp like this. Is there any play in that socket? Sorry, I'm trying to do this one-handed. Not that I can see. Let's clean the socket first. Do the basics. Clean the socket, clean the valve, straighten those pins up, and see how we get on. Better, but not perfect. This one in particular is quite bent. Might have to get on that with a set of pliers. Still doing it. Bad news. Let's put a new valve in. Try that. Brand new tad red base in there. It's not the valve, so we're looking at either the socket, the solder joints around the socket, which I'm going to reflow next, because I really don't want to have to replace that socket, and those traces do not look good. Right, I'm just scoping the output of V1A. I'll show you on here. So I'm just scoping here, and I'm yeah, I'm here at this point here, and if I tap the board, sometimes you can see it on the scope. Okay. However, if I scope the input to V1A, you need to come out of it. Ooh. You see how it's still there on the input? So the noise is being generated before the valve, sorry, yeah. So let's start by getting rid of C3, putting a new cap in place. Let's start with that, because we've isolated it really to 1, 2, 3 or 4, 5 components if the noise is still here. We can see it on the scope here, then it's got to be one of these components. Let's start with the cap and go from there. Right, I'm a bit further down the road. Sorry I didn't film anything. I was just cracking on trying to get my head around this thing. So I found numerous things. So 5 capacitors, 1, 2, 3, 4, 5, 3 disc, 1 polypropylene, and that 2N2 are all leaky if you apply working voltage to them, they are all leaking. So they've all been swapped out. Some of the crackling has gone, but there is still issues, and it's definitely around V1. So at this point, and doing some research online, speaking to some other people who've done more work on this particular model than I have, they recommend swapping out both of the preamp sockets with some better ones. So I'm going to get some of those on order. The customer said do what is required, so that's what I'm going to do. But until they arrive, I can't do much more on this amp. But yeah, not overly impressed with the design of this thing, to be honest. I mean, you can see just how many of those traces are bubbling and starting to peel. It's not good. Apparently these also had output transformer issues, so I'm hoping we don't get into that. But the issue is definitely around V1. So it's going to be a new socket. Well, there she is then, the beast, the Ampeg V4B, and this one is one of the originals from the 70s. I'm not sure exactly what year it is. We'll have to find that one out. I can't remember off the top of my head how to date these. So we'll have to look that up, work it all out. But it is the classic V4B. A couple of stickers on there as well, look. So what were these? They were 100 watt bass heads. Absolute beasts. And this one, unfortunately, is in, well, not unfortunately, to be fair, it's in for resurrection. So it's been stored for the last 20 years. That's the unfortunate bit, that it hasn't been played for such a long time. But it's been stored for, he thinks, over 20 years. He's not entirely sure exactly how long, but he hasn't used it. He doesn't remember there being a problem with it when he did put it into storage, but it's now been sat for 20 years, and he didn't want to plug it in before getting it checked over, which is the right thing to do. And of course, you lot all know that because you watch the channel. Right, so let's have a look around then. 2 inputs, conveniently labelled 1 and 2. The classic Ampeg logo. It's a shame that the control plate has started to wear like this, but that's where we are. 2 volumes labelled 1 and 2. Treble middle bass channel, and the mid-range. I thought these were notched, but maybe they're not. Well, this one isn't anyway. I haven't seen an old Ampeg, certainly one of this era, for a long time. So you're going to come on a learning process with me. Power switch, standby switch, and it's got the 3 EQ switches up here, which unfortunately don't feel great. That's a 3-position switch, that one. These 2 are just on or off, but they do not feel nice at all. We'll have to get inside, find out what's going on with them. The other cool thing is that the chassis are shock mounted. So you see how they move? Because they are, as far as I remember, shock mounted inside the cabinet, which is amazing. Love that. So, but you guess what though? This is not the only Ampeg the customer brought in. He's brought in its baby brother too, the little Micro VR. I remember when these came out, I thought they were really cool. What a great idea. A little practice Ampeg bass head. You can see what the problem is. It's had 2 knobs broken off. All the pots are broken. He's kept the knobs so we can reattach those, but we've got to put new pots in inside. I can't remember. I know it's a PCB amp, but I think the control board is separate to the main board, which should make things easier. But yeah, we've got to source the correct pots for this, and then we can put the knobs back on. That's all that this one needs. But that's just a minor job. We'll put that to one side. Let's spin this thing around, have a look at the back. Here we go then. So it's got a UK plug on it. So it's had a conversion because it is, as you can see, originally wired for 120 volts. So at some point in the past, it's had a 240 volt conversion, and I hope that's been done well. This mains cable itself, it's still flexible. Let's put it under some strain. Yeah, that's all right. But he did give me permission to replace that if it needs doing. So if it's had a UK plug on it, oh, excuse me. Let's have a look at that then. All a bit dusty. Some spider webs. We'll have to open that up and check inside. Make sure it's all good in there. So serial number is 166785. What have we got then? Got all of the valves labelled on the back. So the output valves are 7027s, 1, 2, 3 and 4. It is a 100 watt amp. 12AU7, 12AX7, a 12DW7, a 6CG7, a 12AX7, a 12AX7 and a 6K11. I think they're the really tiny ones, aren't they? The really small ones, if I remember. I bet I'm wrong, but we'll open it up and have a look. Got 2 speaker outputs. It connected in parallel, and we've got an impedance selector here for 2, 4 and 8 ohms. Right. Oh, we've got a preamp out and a power amp in. Very nice. And a hum balance pot. Right, let's get this back panel off. It's not screws, it's well, I guess they are screws, aren't they? But they've got a hex head as well. So I bet that's 7mm is the modern equivalent on that. No, it'll be 1/4 inch then. Okay, let's get this back panel off. Let's get the chassis out and have a look inside. Back panel off. There's the original sticker. V4B, model number 110, serial number 166785. Matches that one. 120 volt. Very cool. The Ampeg company, Elkhart, Indiana. Right, let's get this thing apart. I just remembered the 6K11. It's short, but it's fat. There it is. Magnavox. Let me get a 12AX7 so I can show you. So that's a 12AX7 next door. You can see it's slightly shorter, but much fatter. 6K11. Okay, chassis removed from the cabinet on the bench, and I love this. I love it when you get the schematic, the correct schematic for the amp printed. Do you remember how we had it on the B15 as well? But here we go. So I know it's upside down. I have to come round. I'll just show you that. Very cool indeed. Love it. Absolutely love it. Right. So, as I said, the chassis itself sits on these shock-mounted things here. And these are bolted into the side of the cabinet. So what I'm going to do first is flip this thing over so we can remove these and then we can work on the chassis easier. Then we can inspect the transformers and all those other things too. First thing I notice is somebody scratched their name into this. B. Veryard. Can't work out what that says. Ganvey? Maybe? It doesn't look like that wide, does it? Can't tell. Anyway, right. Output transformer. Yes. Output transformer. There's the numbers on it. My brain's gone blank. I can't read these today. What's wrong with me? What about the mains transformer? Nothing written on that one. Couple of chassis stamps on this. 732313-2, 732313-4 on that one. So let's have another look at this 6K11 then. It's got a load of pins on the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Amazing. Right. You see anything in there? Interesting. Right, so I've noticed one thing. So these are the 7027 output valves. If you look at the top of this one, it's gone all clear. Three cap cans, these two Nichicons, dual section 100 microfarad and 40 microfarad on that one. That one's the same, sorry. And this one is a 40-40-40. Very cool. Right, that's the top side. The other thing I was going to say actually. So here's the shock rubber mounts. Unfortunately, one of them was broken, which is a shame. So I'll have to have a look to see if there's a way we can fix that. Yeah, let's flip this thing over. Let's get the upper panel cover off, and we can finally look inside the chassis. Here we go then. So, having a look around, first impressions, I can't see anything out of the ordinary. Maybe some of the resistors are looking a little bit worse for wear. There's a cap all the way over in this top corner, which looks like it's been having some fun. Nitronics. And these two power resistors as well. But the cap cans aren't exploding. All look okay. This one up here is Mallory, possibly. But do you know what? I don't see much reason why I couldn't soft start this slowly, really slowly. So if I, do you remember I was saying how you could use a variac to soft start an amplifier, and how I never use one because you can do everything with a light bulb limiter. Well, this is a 100-watt bulb. If I start with a 10-watt, soft start the amp. Remember, the bulb's going to protect the amp from any excessive current draw. Then go to 25, then a 50, then a 60, then an 80, then up to the 100. You could do it that way. I'm really tempted because I'm not seeing anything in here so far that says to me, do not fire this thing up. Haven't made my decision yet. I might carry on, do some other measurements first, at least do some basic checks. I need to make sure that it is indeed wired for 240 volt. Need to work out how they've done that. I get the schematic. So it shows you how to wire it for 240 volt here. So I need to confirm that that is indeed how it's been done. Once I've done that, oh, do you know what I could do actually? Do you know what I could use my bench power supply and just energize the high voltage rail ever so gently. I could, start with 1 or 2 DC volts and slowly bring it up. Yeah, that might be a fun thing to do. And then we can see how much current this thing draws just on the high voltage rail. So we'll remove all the valves, remove them all entirely, and then we can just connect onto any part of the B plus rail and just apply a very low DC voltage and slowly turn this thing up. And we'll leave all the other circuits unenergized. That would be a cool thing to do, actually. Yeah, let's do that. Okay, so we're all set up then. So I've got the Heathkit power supply, the PS4 model. Interesting fact, it's got a pair of 6L6s inside it. Anyway, this essentially becomes the mains transformer in the amp. So from this, I can supply the heaters, I can do the bias supply, and I can even do the high voltage, which is what we're going to do. So I've connected it up inside the amplifier, and we've essentially, the positive is feeding the is essentially taking over the bridge rectifier. So we're feeding it in at the same point there, and the ground goes to the ground rail of the B plus rail, B minus as we'll call it. I've also got my meter hooked up just so we can measure the output digitally as well about with the analog scale. So this is the output voltage on the left. See, we're currently down at 0. The unit is on standby anyway. But we can also measure the DC output current. So we can measure how much current is being drawn through this. So what do I expect to see? Well, as I increase the voltage inside the amplifier, bear in mind I'm just energizing the high voltage rail, nothing else in the amplifier. The valves aren't warmed up, so they're not going to conduct. We can then see how much current flows. Now, as these caps start to energize, we will start to see some current flowing, and we should see that needle moving around. If it goes above that red line, 100 milliamps, I'm going to switch the unit off. It shouldn't be anywhere near that. I mean, at most, once the thing's settled down, 10 milliamps maybe. That's about it, but we'll see. But we'll monitor it anyway. So I'm going to set this up so you can see both scales. Like that. Can I make that easier for you to see? That's currently reading millivolts. We make this easier for you to see on camera. Is that better? That looks a bit better, doesn't it? So I'm going to switch this into play mode, and we are going to slowly, very carefully, energize the B plus rail. This is another way to reform caps, if that's the way, if that's what you're interested in doing. Right. On we go. So I've turned the unit on, and we're now putting 6.97 volts into the amplifier, just in the high voltage rail. Yep. And as you can see, the current meter up here still reading 0. So there is no current flowing at the moment. But we'll just leave it as it is, and we'll see what the voltage does. And I've got my dial down here all the way counterclockwise, so it's not doing anything. The first time this amplifier has been energized in a very long time. It's just the high voltage rail. So I'm just going to leave that for a bit. Hopefully it will stabilize at a decent point. I'll come back shortly. Okay, so that's stabilized around just over 7.5 volts. It's fluctuating between 7.56, 7.58. It's going up and down a bit, so we'll just leave it a little bit longer, see what it does. Okay, so at the moment I'm quite happy. Bear in mind this high voltage rail, according to the schematic, runs at 545 volts. So we're just over 1% of that. Right, I'm going to turn the dial slightly, and we're going to increase the voltage up to about 10 volts. There we go, starting to come up now. So we're slowly applying a tiny bit more voltage into the high voltage rail. And our current meter has still yet to move. So there's still no DC current flowing, at least not what we can measure on the meter. We'll see if that stabilizes. I'd like to get this up to about 100 volts. I think that'd be a nice place to go. I can go all the way up to 400. But I think for our very first start in a long time, just gently applying some voltage is a good thing. Now, interestingly, I know you guys haven't seen this on the channel before, this method. This is what I'd do if a really old radio came in. You know, an old radio or radiogram, definitely something from the 30s or the 40s. You'd very, very gently energize that chassis, that high voltage rail, make sure there's nothing going on. If there is a short, I can quickly shut it all down. Benefits to this over a variac is that I can control which circuit in the amplifier I want to energize. Whereas if I used a variac and plugged the whole amp into that, you're not only energizing the high voltage, you're doing the heater supply, the bias supply, and anything else that might be in there. But here I've got much more control over it. There you go, 10.34 volts, that's nice and stable, no current draw. Would it be easier if I turned this and you can see, get more square on with it? Yeah, that looks better, doesn't it? Right, I'm going to up it now to around 20 volts. And remember, you're just watching that current dial. This one here, for any fluctuations or changes. Excuse my arm. There you go. So there's now 20 volts DC inside the amplifier. And it hasn't moved. If there was a short, then that would be moving. But there's not so far. It's nice and stable. This is all good news. Bit more. I did see that needle flutter ever so slightly there. We're up to 30 volts now. Just over 50 volts now. Nice and stable. No smoke, no fire, nothing complaining, no excessive current draw. In fact, there's no current draw. This is excellent. And 50 volts is not an insignificant amount of voltage, right? I mean, that's if it was negative voltage, that would be, you know, a good bias voltage. That's just a standby switch. I was checking it with a cut the B plus. Quite boring, really, isn't it? 150 volts. Okay, so at this point, we've got 150 volts inside the amplifier. Let's go and measure some of the other B plus points. See, there's 150 volts there, you see? At this point here. Let's check this can cap over here. 141, 144, 141. Right down there. Let's find a preamp socket. Pin 1 on V1. 141 volts. Out. Output valve socket. Let's find pin 3. 1 down here, sorry. 1, 2, 3. That's the anode. 150 volts on the anode. Pin 4 would be the screen. 150 volts on the screen. Connect the meter back into our measuring point. There it is, 150 volts. Excellent. Nice and stable. This is good news. This tells me that these caps are actually, so far, in pretty nice condition. Let's bump to 200. You'll notice that the current needle has now come off the very bottom. So there's probably 1 or 2 milliamps of current flowing right now. A bit more. 250, the needle's come off the bottom now. Now we're starting to get something happening. But this is all good. This is what I expect. So that first notch there, 25, if it stays below then we know it's all good. 300 volts. 350. So according to the scale, 5, 10, 50, that's 5 milliamps of current now. What was the maximum for the rail operating? 545, okay. So even if I go up to 400, we're still going to be way lower than that. There's now 400 volts inside this amplifier. And the B plus rail is providing that voltage to all the different parts of the circuit. So, and if there was a fault, we would have seen it by now. This amplifier seems to be pretty good. Seems to be pretty good. So max on the dial is 421 volts. And it's still pulling 5 milliamps of current. Well. She's all good. So just to confirm, if I set this back to 400, oh, too far. What does our volt needle scale? It's bang on 400. Oh, that's accurate. When I calibrated it, I must have done a good job. So there you go. 400 volts inside the amplifier. The high voltage rail is now energized. We all seem to be okay. Okay, so the next thing would be test the valves. I think I want to test the valves. I don't want to power this thing on, apply heater current and voltage to all of the valves without testing them all. So that would be my next step. But I'm going to leave this as it is now. So that's running great. That's a great example then of how you can reform caps, as it were, using a bench power supply without energizing the rest of the amplifier. But yeah, I think this one's fine. It's actually quite good. I'm going to probably replace this cap anyway, because that's the one that looks the worst. But the 3 can caps appear to be okay. So yeah, we'll make a decision on that. It's getting quite late in the afternoon now, and I tend not to mess around with high voltage as the day goes on. But yeah, let me switch this all down, safely discharge it. In fact, if I just put it onto standby mode, how quickly does it discharge? Might need to put a discharge cable on it. Anyway, yeah, we'll call that one tested, I guess. Quite happy with that. Nothing much really more to report until we go further with it. But yeah, Ampeg V4B, small resurrection. Right, I've had a cup of tea and I've had a good think about it, and I've made the decision to fire this thing up on the bench through the light bulb limiter to see what would happen. And it's doing something very, very interesting. So the B plus settled around 320 volts. And it sat there for about 10 minutes. And now it started to do this weird cyclic thing. It gets to 320. Then it starts to drop down to about 220. And an audible hum appears through the speaker. The bulb glows brighter. Then the voltage starts to increase again, the hum decreases, and our bulb glows less bright. And it's been doing this cycle for about 5-6 minutes now. Guess we need to measure that hum, don't we? Okay. So clearly something is not happy inside this amplifier. And this is why you don't just plug these things in without doing your pre-tests and checks first. So even with the light wall limiter in place, it's still doing some weird things. In fact, I've noticed now it's no longer reaching 320 volts on its highest point. So we get 240, up it comes again. About 300. Draws more current down to 240. Swings the other way. Right, okay. So I've changed my mind. I do want to replace all the electrolytic caps in the amp. Because now we've got some weird, strange behaviour I'm not happy with. Not happy with one bit. So I'm going to get some caps on order and take it from there. Well, that's it then, guys. Thank you very much for watching once again. As always, please give this video a thumbs up. All your comments and questions for next week's Q&A down below. Subscribe if you haven't already. If you're feeling super generous, why not join the channel? And I will catch you all at the next one.